All right, day 2 of viewing window. Again, I would take really, really good notes. There is a lot of flexibility in this lesson. So what I mean by that is what you view as the best viewing window, I could say absolutely that is a great viewing window, and your neighbor could pick a different viewing window. Okay, for the most part, your calculators may not generate the same perfect viewing window, which is why you don't want to copy from somebody else for homework or tests in this section. If we look at the first example, which does start with the decimal point 1, and we graph it, what happens in your picture? Do you see anything? You see most of the graph, yes? You see most of it? The problem is you really don't know what happens in that bottom right-hand corner. Agree with me? You're putting it in? Okay. So when you graph this, it doesn't come up perfectly. It's that you can see the meat or the entire major part of the picture. So what we're going to do is we're going to work on changing that. And if you think about it, we can't see the bottom, which is the reflection of the y-axis. So go ahead into window, type on where it says window. You're going to have a list of values. We want to change the lowest y value to something lower than -10. Nope. Go into window. Yeah, it's going to be under y-min. The lowest y value is not going to be -10. Maybe we want to try something with 14. -14, something like that. I want you to change the window settings until you can see the majority of the graph. So let's see, all the way to the bottom, -15. Does that work for you? Okay, can't see, go back in. So what we are working on right now is hand manipulation of the window. Right? Maybe you put in -20. -20 would also be appropriate. So when we talk about this list, and you're going to see that this is the prompt that you're going to get on tests, I think that -10 to the left, 10 to the right is appropriate. When it says scale, it just means how many units per little tick mark along the x-axis. You can always leave that as 1. Y-min, I heard a lot of you say -15. That works. Y-max still can be 10. Scale is 1, and I'll be honest, I don't really care about resolution. I'm really only looking at the 6 values of the table. So I'm going to assume when you do your homework and it says what is the best viewing window, that you copy down those 6 numbers, that those are the prompts. Everyone's calculator is the same when it comes to the list of prompts. -10, 10, 1, -15, 10, 1. Okay? This is an example of one. Maybe you have -20 here. That would be appropriate as well. So the big idea here in this first example is you can change your window very quickly by clicking on the window button and hand manipulating what you want for your values. That's the first example. Okay? How do we get back to the standard window setting? Quickly, efficiently. Zoom 6. That is your safety for graphing, is Zoom 6. So just like second mode is your safety to get back to the working calculator screen, Zoom 6 is going to get you back to that -10 to 10 setting. All right, so now let's go ahead and graph x squared plus 17. What happens when you put this into your calculator? Now, in your notes, if you're wondering what you should be writing down, basically I would put in that list of those 6 numbers from the last example, draw a quick sketch of what the new thing looks like, and maybe even label in your picture so that when you're looking at it, you can say this was -15, 10, 10, -15, and then you draw your little graph. Okay, so maybe that's what you want to put in there just as a reference. You're not going to have a graph for this one. Why not? It's really high up. Plus 17 is your y-intercept. That's going to be much higher than the 10 that's given in the standard window setting. So the quick way to change this would be to go into what? window and change which value in your window? Y max. So go into your Y max, change that. What will you go to? Maybe 18, 20, 25, something so that you can see the majority of the parabola. We know it's a parabola because it's x squared.
After every graph you do, do you recommend us hitting the standard just to get why not?
I would change my Y max now up to like 20, 25, something to that effect. Yep, you can change it if you want to. Okay, now everybody got there? Can you see the majority of your graph? The U? Yes, all right. New commands. Here it comes. Da-da-da-da. Zoom fit. If you click on zoom, we've used zoom standard, which is our safety standard, -10 to 10. Now we can use zoom fit, which the calculator knows is go find the meat of the graph. So now that you've changed your window manually, go into zoom, choose option 0. Do you now see the parabola very much zoomed in? Okay, now how am I going to know you use zoom fit? Click on window now. Look at the weird decimals that you have. Yeah. Zoom 0. Yep, there's zoom fit option 0. This is how I can always tell because I'm guessing most of you are not going to generate a window with those weird decimals. It's not a problem to use zoom fit. And zoom fit, I'm going to say, is going to work for you probably about 90% of the time if you don't see it in the standard window setting. Okay, zoom fit. So when we do that, we get something that looks like this, and we can go ahead and fill in our table based on this picture from zoom fit. One thing that's kind of interesting is depending on the model of calculator, kind of like TI-83 pluses from a certain year always get the same zoom fit. 84s get a different zoom fit, but the programming is the same for the model. So that's how you can kind of tell also which calculator you have. They changed the algorithm for finding the best zoom fit. Questions on that? Zoom fit, new best friend. Enjoy it. All right, now part C, you're going to be asked in your homework, here's an equation, find the best window setting. So go ahead and type in x squared minus 3. And what do you think the best window setting is going to be for this one? Does the standard work? If it ain't broke, don't fix it. Standard window setting is appropriate. Okay? So you can just note that standard -10 to 10, -10 to 10, 1 and 1 for your scale. All right, so for those of you that are like, this is so boring, this is ridiculous, now we're going to do something a little bit harder. Not mathematically harder, but it's an analysis harder. So this is where we're going to start to really look at, this is what the graph looks like, this is what the calculator says, how do we merge those to make sure we understand the same thing. So if you take a look at letter D, does everyone have this equation in their notes, x squared minus 6? Okay. Anytime, quiz, test, moving forward, that they ask you, what is the window shown? That's going to tell you, most of the time, should be anyway, that I have gone in and changed these window settings. These are not the standard window settings. And so I'm not going to worry about the resolution. The way that we will figure this out is to use intercepts. So the easiest way to see your intercepts is to use the standard window setting on your calculator. So let's do that. Everybody go to standard. Let's type in. Okay, let's turn this on. Let's bring this up. And let's actually type in the equation that was given to you. It's not a lot of fun. So x squared. I have here x squared minus 6. I know you can't see it. I'm going to fix that in a second. There we go. x squared minus 6. So notice this is my Zoom 6 on my calculator. This is the picture I was given in the book, on the test, in a quiz, in your homework, whatever it is. And now we're going to compare them. So if you look, since this is standard, these are all scales of 1. 1, 2, 3, 4, 5, 6. Doesn't this cross at negative 6? Okay, if that's negative 6, this is also negative 6. That didn't change. It's the same equation. So what does that tell you about my scale in this picture? My y scale is now going to be 2. Before I go on, are there any questions how I got 2? Think about it.
It was like the opposite would it be 1.
It could be, but I'm not going to give you one. It won't be fractions. It'll always be like bigger scales. Okay? So in the standard window setting, when we compare them, the count here is the same value as what you're seeing in the revised window. Okay, so if I know that that has a scale of 2, doesn't that mean that it goes down negative 2, negative 4, negative 6, negative 8 is going to be my y minimum, the lowest value of y. 2, 4, 6 is going to be my y max. You don't have to give me decimals, give me the closest value. We can determine how high, how low. Now we do the same thing with x. So if I look at x, this looks like it crosses here at like a little more than 2.5. Okay. Doesn't it look like it crosses here at a little more than 2.5? So that tells me the scale of x is the same. The scale is 1. Omar, question.
So if you can kind of see it, the negative 10 spot on the y-axis, you put y
If yours goes down another block, like a negative 10's fine. All right, so here's an example where I didn't change the scale of x, but I did truncate it. I made it a smaller x-axis piece. So notice mine only goes up 1, 2, 3, 4. Positive 5 is my max. 1, 2, 3, 4, 5. Negative 5 is my min. If I would now go in to this equation, y1, and type in these actual values, it should look exactly like this picture. And that's a check that you can actually do. Questions on that? So identifying the window that's given to you, we're going to compare it back to the standard window. Now, I always get this because there's a question in the homework about it. Well, what happens when I go to graph in standard and I can't see it because it's too far down? Well, then you're going to zoom out and you're going to count. Keep the scale 1, change your window, maybe it crosses at negative 14. But over here it looks like it crosses at negative 7. You might have to change this, but always keep the scale 1. That's going to be the easiest way to do it. Or you have to go in and use the commands that we used before finding the x-intercepts and y-intercepts to find the ordered pairs. Okay, so here's a U-try. You don't have this one, but I just want to review the steps. If my graph, which I have here, is x squared minus 9, put that into your calculator. X squared minus 9. Where does x squared minus 9 cross the y-axis at? I heard it. Somebody said it. Negative 9. So that tells me my y scale is how much? 3 units. So I've got my y min, y max, and y scale now is 3. Y max is going to be 6. Y minimum is negative 12. What about for where it crosses x? What is this value in the standard window setting? 3. So what's my scale here? 1. X max. X min. 1, 2, 3, 4, 5. Negative 5. 1, 2, 3, 4, 5. Yes? Does that make sense? What is a good window? Go ahead and graph negative x squared plus 19. Is it the standard? Is it something else? That's what you're basically looking at by using your calculator. I'm guessing most of you see the standard would not be appropriate. Yes? We have a y-intercept all the way up here at plus 19. This is a parabola that opens downward. Two options. You can manually change the y-axis, the maximum. Change that to 20, 25, something like that. Or your other option would be to use Zoom Fit. I don't care what you do, they're both appropriate. Okay? Yes? The only problem with Zoom Fit is that if something works in the standard, I want you to use that. I want you to use Zoom Fit only when standard really isn't appropriate. It'll work 90% of the time. Sometimes on the calculator, the way it's programmed, like that one that we looked at with the loop down here, sometimes it'll focus in on that first bump and forget the second one that you would see in general before you changed it. All right, last skill with the calculator. This is the last skill of the unit. If you look online, I'm going to show you here in a second. We are going to have a formal 30-minute quiz all about the graphing calculator on Friday. Even if we don't have school tomorrow, that quiz will be on Friday. That'll give us a day to go over homework. If you still need help or extra time, you can do that on Thursday. Yes? I don't think it's going to be that bad. It's supposed to warm back up. And no, I mean, we have a parking lot that is an ice skating rink right now. We have teachers falling down in the morning because it's dark and don't see ice, and they're just like, we'll charge you a sick day. Have a good day. Go home. Like, put some salt out, for God's sakes. I don't get it. If any of your parents are maintenance workers, I'm sorry. I'm not trying to be a negative Nelly, but true story. I was 6 months pregnant and fell here. 6 months on the ice.
I fell in LA. Just like I hit my head. She fell so hard. My feet came out from under me, and if I didn't have my book back on, my head would have been.
And what's crazy is if you come to my house and slip on my walk and fall, you sue me. But if I come to work and slip and fall like that, there's nothing you can do. Fantastic. So yes, all right. So finding a vertex, last skill. Sorry, I'm all over the place here for a second. In your calculator, you would put this in as your y1. You would graph it. You would make sure that you have to be able to see the vertex in the picture. If you can't see the lowest or highest point of the parabola, the calculator can't calculate it. Okay? Now, to find a vertex, I know that you learned a bunch of things. We will do this in later units. Right now, we're using the calculator to come up with these ordered pairs. So we're going to actually go into the command of second trace. And you have to be a little bit aware. Do you think with this picture I would have a minimum vertex or a maximum vertex? A minimum. So the point that is going to be the lowest in this one is going to be the minimum. And what does it prompt you when it says minimum? Okay, so I go into my y1 and I put in x squared minus 4x plus 1, and I look at my graph. I go into second, calculate, I choose the minimum value. Now, this is where these are $100 calculators. Obviously, the minimum exists on the screen, but the calculator wants a little help. It's going to say, I want a left bound. So I'm going to use my cursor, and I'm going to move it to the left of where I think the vertex is. So I actually use the cursor to move it to determine where the left bound is, and I hit enter to tell the calculator I want you to use that as the left point right there. Now what does it prompt you for? Right bound. So I use my arrows and I go to the right of that key point over here. This is going to be my right bound. This was my left bound. Okay, what I've done now is I have restricted the parabola to only this little bit of the curve. What is the last thing it asks for after I hit enter?
Yes.
Guess. Calculator says, you know what, help me out. You tell me where you think the lowest point is so that I can start calculating from there. And I come back to about the closest spot. I hit enter. So right here's my guess. And what it literally does is what's called interpolation. It'll go back and forth until it finds the lowest point, and then it'll stop on the lowest point. This is where I got my minimum. It's going to be an ordered pair, 2, -3. Done. Yes. Okay, so let's talk about some of the calculator weird things that happen. Because it's going like this and calculating, it's going to find the closest 1.999. You can always estimate to be -2. Okay, so if this value says 1.99999, you can just say that this is 2. Also, if you get something, let me switch colors just because, if you get something that says like 7.2 e to the negative, like it'll be like -21. That means take the decimal, move it left 21 places. This is an approximation of 0. Okay, it's not being tricky, it's just because it's literally doing these mathematical calculations to figure it out. So anything that has e to a huge number, -10, -21 is an approximation of 0, 1.99999 is an approximation of 2. There are some assumptions you are allowed to make with the calculator.